Hey guys! So in this video we're going to take a look at how to solve simultaneous equations by using the elimination method. I'm just going to be taking you through a couple of examples. Okay, in this first example we have 8x plus 11y equals 38 and we have 4x plus 5y equals 18. Now when we're being asked to solve the simultaneous equation, what we're trying to do is to find an x value and a y value which will work for both equations. And there are several ways of doing this. We can do it by drawing graphs or by using the substitution method. And make sure you check out my video on the substitution method if you're not familiar on that, because I went through a few examples on there. But in this video we are going to focus on the elimination method. So I'm just going to talk you through that. Right, in the elimination method the aim is to get the x values or the y values to be exactly the same for both equations. So if we look at the second equation, if we were to multiply it by 2, then we would get the x values to be the same for both equations. So I'm going to rewrite the first equation first. 8x plus 11y equals 38. And now we're going to multiply the second equation by 2. So 4x multiplied by 2 equals 8x. 5y times 2 equals 10y, and 18 times 2 equals 36. So now we have the situation that we wanted. We have the x values which are exactly the same. And because we now have that, we can begin with the elimination process. So all we're going to do is to take the second equation away from the first one. So I've got my minus sign here. 8x minus 8x equals 0. 11y minus 10y equals y. And 38 minus 36 equals 2. So if we cancel out the 0, because that's nothing, we get y equals 2. So we've actually done the first part of solving the simultaneous equations. We found out the value of y, but we haven't actually finished the question yet because we still need to find a value of x. And the way to do that is to use our value of y and put that back into either of the equations. It doesn't matter which one. So I'm going to use the second example. 4x plus 5y equals 18. We know that y equals 2, so we can rewrite the equation. 5y, 5 times 2 equals 10, equals 18. So the next step is to take away 10 from both sides. And this will give us 4x equals 8. So by taking away the 10 from both sides, we have now got all the x's on one side and all the numbers on the other side. And all we need to do now is to divide both sides by 4 to get x equals 2. So we now have our solutions. Y equals 2 and x equals 2. And if we're to put these values for x and y back into the original equation, it's going to solve both of the equations. Right, so let's move on to our second example. Okay, so in this example, 5x plus 7y equals 27, and 2x plus 3y is equal to 11. Right, so as I said earlier, the step one in solving simultaneous equations by elimination is to make sure that either the x values are the same or the y values are the same. So in the previous example, all we had to do is multiply one of the equations. But in this one, because 2x doesn't go into 5x and 3y doesn't go into 7y, we are now going to have to multiply both of the equations. So earlier on we focused on the x's, so this time let's focus on the y values. So we have 7 and we also have 3. Now the easiest way to do this is to multiply the 7 and the 3, and this will give us 21. And 21 is actually the lowest common multiple of 7 and 3. So our aim is to rewrite both of the equations and to have the y value equal to 21. So if we focus on the first equation, what we need to do is multiply all of that by 3. This will give us 15x plus 21y, there it is, that's exactly what we want, is equal to 81, and that's because 27 times 3 equals 81. Right, for the second equation, again we want the value of 21y, so we need to multiply all of the second equation by 7. And this is going to give us 14x plus 21y, there it is again, equals 77. So now we've got the perfect situation. We've got the y values which are exactly the same. And this now enables us to start the elimination process. So again, we're going to take the equation away from the other. 15x minus 14x is equal to x. 21y minus 21y is just equal to 0. And 81 minus 77 is equal to 4. So the zeros cancelled because it's equal to nothing. And this gives us x equals 4. So again, we have one of our solutions, but we still need to find out the value for y. And as I said earlier, the way to do this is to put our x value into either of the first equation. So I'm going to choose 2x plus 3y equals 11. We know the value of x, it equals 4. So 2 times 4 is equal to 8, plus 3y is equal to 11. Again, we want all the y's on one side of the equation and all the numbers on the other side. And the quickest way to do that is to subtract 8 from both sides. And this will give us 3y equals 3. And then all we need to do is divide both sides by 3 to get y equals 1. So here are solutions. X equals 4 and y equals 1. And if we were to put these values for x and y back into the original equation, they're both going to work. So that's how you solve simultaneous equations using the elimination method. I hope you found this video useful and make sure you subscribe to my channel for more videos. Bye!